VPC, virtual private cloud, right? If you think about since when we started this class, we've been doing so many things, right? We've like deployed this into instance, for example, tested it via the browser. But in all these cases, we've been using the default VPC, right? So the VPC that comes with the environment. And the way it is right now, it's basically a public VPC, right? We don't, it doesn't really have the concept of anything being private. It's just public. So anything you launch in there, you can see it via the internet, especially if it has a public IP address, and we'll see what is making that to happen, right? But in the actual sense, VPC itself means a virtual private cloud, which means that inside of the AWS infrastructure, you can have your own virtual private cloud, right? Which means that if you have it, you can choose who can see whatever you have in that VPC, and we'll see how that is. So we'll see VPC basics, right? We'll talk about IPv4 versus IPv6. I think we'll just revise it. We've talked about it already, right? We'll look at security groups. We've used security groups several times. We'll just see a new one, which is network access control list, right? We'll see. I don't think we'll be able to get to the connectivity option because I want to delve deep into endpoint at some point. Cost optimization, best practice, hands-on VPC walkthrough is some of the things we're going to see in this class. So what's a VPC? A VPC is basically a virtual private cloud. What it means is that inside of the AWS infrastructure, in as much as the cloud platform that's giving, like it's a place for you to do your cloud computing needs, you can have your own private setup, right? And that's just the concept of VPC, meaning you can have your own private cloud, right? So what it means is that anything you keep there is private unless you want to expose it to the outside world. And we'll see how you can do all that as time goes on. Because the whole idea is that not everything is public. Some things will be made public. Some things will continually be kept private, right? Because you don't want people to be able to access them, right? And the reason is also sometimes it's good for you to more or less like for you to reduce the blast radius if something goes wrong, right? Because if everything was to be public, you're more or less like increasing your attack surface, right? It means if someone was planning an attack to you, they can do it across all your services. So a VPC can help you shield some services such that it's away from the public eyes, okay? So your own section of the AWS cloud, that's just what it means. AWS, as you've seen, is a global infrastructure, but you can have your own part of the AWS infrastructure kept for yourself and kept private. So complete control over your virtual networking environment, exactly. So you decide exactly how you want to structure it, and what are the entities you want to have within your own private setup, right? And then we'll see, spans all availability zones in a region. Yeah, if you design it that way, right? Default VPC also versus custom VPC. Like I said, all the examples we've been using default VPC, but you can have your own custom VPC, right? And the benefit is really control. You can control, like more or less like have that security control flexibility. That's really the benefit there, because it means that if you can have your own private space, you can choose exactly how you want to manage your resources in there and who can have access to it. So if you think about it, right, IPv6 is the new kid in the block, right? And there is right now there is still people are gradually transitioning into IPv6, right? So if you think about an IP address, most of the ones we are used to is really the 32-bit IP address, right? IPv4. But there's new IPv6, 128-bit address that is in that format. And what it means is that as time is going, people are already doing that migration. They're trying to more or less like have like hybrid workloads. Some are using IPv6. Why? Because IPv4 there's just that number limitation, and we're already lacking IPv4, and you are always encouraged to use IPv6, right? Not much in the private sense, but much in the public sense, because there's just how many public IP addresses you can have for IPv4. But IPv6 plans to solve that problem, and you should know that your IPv4 in your account, they cost money, right? So you know that we've talked about that before. IPv6 is free, right? But obviously optional in most of our AWS services we've seen. There's dual stack support, so your VPCs can support you having both IPv4 and IPv6 workloads, right? So, and the reason you ever think about IPv6 is just to move away, like have your IPv4 conservation, right? Not completely exhausted, so you can have a mix. But again, it's like an adoption phase, but it's good you know that those two options are there, okay? Some people are already planning to move. You also need to put a lot of things in consideration, so I won't dwell on it. So let's now think about before IP addressing. There used to be like the legacy class-based addressing. Let me just zoom my page a bit so that you see what so that you can see it clearly. But there used to be the legacy class-based addressing, and I'll just talk briefly about it because that's not the essence on the class. So in the early days, there used to be like 3 classes of IPs, right? So you had the IPs that were class A, there was class B, class C, and the whole idea was that there was this mask that you could have around those IP addresses that decided in more or less like how many IP addresses were in there. So you had like a fixed class you could work with, right? Although you could break those down, but the thing is that there were a lot of problems around it. Number one, it was inflexible, right? It was not just easy to just work with. That's number one. It was inflexible, not easy to work with. Secondly, it was really wasteful. You couldn't really have like very small classes without using any of these class A, B, C. You couldn't do all that. Okay, and you saw I introduced the fact that IPv4 there was this exhaustion problem that is making us move to IPv6, right? And class A, class B, class C were really one of the ways where people were just exhausting that IP address, right? Because if you look at the class A network, for example, if you wanted to, most times if you declare like a class A network, you were pretty much not using it. You were not using most of the things in the class A network, but you had to choose it because you had to belong in one of the class, right? So it was really a major problem, and that's why the world started moving into like the classless based addressing scheme. Okay, but you can go ahead and read more about it. It's really not about what the class is about, but I'm just here. It's here so that you think about it as something you need to look at. It's like a history class now if you look at it that way. So that introduced the classless addressing scheme, right? Meaning we moved completely from having like classes, right? So class A, class B, class C, all that moved away, and we moved into like a flexible subnet max length. And the whole idea is just so it's called, so when you see CIDR, right, which is something you're going to see in your AWS journey, it's really classless interdomain routing, right? So it replaced the need for our classes. And what did that do? That basically introduced more or less like subnet mask length, right? So you see /8, up to /30. And that actually decided what the network should look like, right? So instead of you having subnet mask where the first, for example, the first 8 bits were for the network and the others were for the host, in this case, you could decide just using the prefix length there, right? So, and again, if you look at the way IP addresses work, there is like a range, right? So there's the 10.0.0/8, which is more or less like equivalent to the class A, the previous class A class. There's also the 17.16 equivalent to class B, and then there's 192.168.000, equivalent to the class C. But the whole idea is that within there, you were not boxed to any of the class issues that we've had. You could take that network and just take a segment of it and say that is your side, the side that you want to work with, and then build every other thing beneath it. Okay, which wasn't really flexible in the days of the class-based addressing, right? And then obviously it addressed the public versus private addressing, right? Because whenever you see any IP addresses like this, they're all private IP addresses. So ranges that are in here are private, and there's the ranges outside these that could represent public IP address, right? So that's why sometimes you see your public IP address, somewhere like 34.10, they never fall into this range because this range are really the private IP addressing range, okay? And then obviously with network address translation, we could reuse these IP addresses, right? We could obviously just reuse them, and everyone can use the same IP addresses within their own network. But when they are going into the internet, there is like a network address translation that happens, and then you are more or less like masked away from their own like the IP addresses they are using within their local network, right? So when you look at like what is this, like when you look at the CIDR notation that I just mentioned, it's basically something like it's obviously classless interdomain routing, right? So the format is IP address, whatever IP address. I think for the most part in this class we've been using /32, /32, and I'll tell you how that is derived. But /32 is basically yeah, you see a formula, but the whole idea is that there's usually an IP / the prefix length, right? And the prefix length just tells you how many IP addresses for the most part are in that range, right? So for example, if you had like 10.0.0/16, there's a formula that says for you to know how many IP addresses should be in that CIDR, you have to do 32, because the way the IP addresses work, it's like 8 bits, right, in 4 places, right? So if you do 8 plus 8 plus 8 plus 8, it's like 32, right? So when you do 32 minus the prefix length 16, it gives you another 16. If you do 2 raised to the power of 16, it gives you the IP addresses in that range, right? Just know that outside that, every other thing will represent the network itself, the network, and then the 65,536 will give you the range, right? The range of the IP addresses that are within that CIDR. So if you do /24, exactly, the formula will be the same. It's going to be 32 minus 24, 2 raised to the power of that. That will give you 256 address. If you also do /28, and that's why you see that /32 is going to give you 32 minus 32, 2 raised to the power of 0 is going to give you 1. That's why you have one address as part of like when you use your IP address /32, okay? But one thing again that is also important when you're pretty much designing CIDRs is that there is need for overlapping CIDR blocks, okay, when you're designing, and we'll see what that entails too, right? And then when you have like a CIDR, like you've chosen a CIDR, AWS will usually take 5. Please don't forget this. AWS will usually take 5 for their own personal needs, and then whatever is left in there will be given to you. So you have to take note of that. When you're designing a VPC CIDR, for example, you have to pretty much understand that AWS is going to take 5 of that. So whatever you're factoring, just know it's -5, right? But I did put a link here. If you just wanted to see more or less like what's a CIDR, what does it look like, you would see that. You see, there's like you can get more information because we can't spend the whole class talking about it. Um, but let me show you. Let me go to this page. I have something here that I wanted to show you. Just a quick. We'll come back to it, but I just wanted to show you one of these ones. Okay, I think I have this link handy. Okay. So what it means is that what it just means is that if you see, I think this is like a good place for me. That's the only way I can. It's easy for me to explain it here. So when you see this calculator, for example, right, just know that everything you see, like in the networking world, especially around AWS, even in big corporations, right, they usually start with a very huge CIDR, right? So look at the three classes of IP addresses we showed. Like, you know, if you check the slide, at the beginning, I showed you this one. So if you think about this, the first class, right? So if we do 10.0.0.0/8, so we'll do 10.0.0.0, and then we'll do /8, right? So this is networking. This has nothing to do with AWS basically. This is basically you planning a network. When you see this, if I want to calculate how many IP addresses, how did it come up to this range, right? This is basically 32, right? I can do 2 raised to the power. So 2 raised to the power of 32, right? Minus, so I'm going to do minus whatever is here, right? So -8, good. And then I'm going to do this. So this will give me 16 million, right? 16,777,216 IP addresses, right? So that's what this address means. So if you were in an organization, for example, I think an organization will start by picking a very huge, like a very big CIDR range like this to say, okay, we know that all the applications we are going to work with, we won't use more than 16 million IP addresses, and they will start from there. And then I think the major work will now be to break these things further. And however you break it further, it doesn't concern anybody really, because I can begin to break out addresses from this 10.0.0.8, right? So for example, if I want to decide the first 256 IP addresses, right? So 256 is pretty much I'm working here. I'm working this complete block, right? Because if you go back to the calculation, these are all bits. I don't want to go into the math details, but if you do 2 raised to the power of 0, 2 raised to the power of 1, you know, because of the indexes they do, and you add everything, it's going to give you 256, right? But because you are doing from 0 because yeah, you're starting from 0, it will now be 0 up to 255, right? So what it means is that if, for example, I want the first subnet in this block, in this whole range of 10 million address, and I want the first block to more or less like be 256 IP addresses, right? So what I can do basically is to say, if I come here and I'm thinking of what will give me that 256. I think 24 is going to give me. So if I do this, 2 raised to the power of 32 minus 24 is going to give me 256 IP addresses. So what it means is that if I want to take the first block out of this place right now, I can just take these to be 24, like I mentioned, right? And that's it. I've already broken this down into a small block out of the large block that we just saw. And honestly, that's everything you need to know about how CIDRs work, right? So people usually start. So the VPC that you see will start from the CIDR, and that is broken down into subnets, right? And we'll see all that as we go. But beyond the VPC level, most organizations usually have like an org-wide CIDR that they are using. So they can pick like one huge one and then break it into different accounts, break it into environment. And that's what I just did. So I just created the first simple one, right? So what I just did was to create a block of 256 IP addresses, right? So it tells me that the first usable IP is 10.0.1, which is fine, yeah, 10.0.0.1. And the last one will be 255. It means that if I actually want to start a new block, I could just, because I know this old part is going to be exhausted, right? I could increase this by 1. And that gives me, you'll be wondering, nothing is changing, but something is changing because now the first usable block becomes 10.0.1, right? And then it's going to start with 1, and then it progresses again down to 254, okay? So just think about it that there's like a huge block and you're breaking that blocks down. And that's what happens when you break a CIDR into subnets. And you can also repeat that same task for a big, more or less like an org will say this is a CIDR, and then they'll break that CIDR down into different accounts, into different environments. But basically that's what you are doing. It's just that these things that I'm doing manually, code, even within your infrastructure as code, you can do all that calculation. But there's need for the planning, okay? You have to plan this first before that can take shape. Just so you know, this is not a deep networking class, so I might not be able to go in depth, but it's not hard. Like there is usually a large group, and then you break those large groups into smaller groups for you to get the results you're looking for. Okay, so that's basically how they came up with these numbers. It's really, you know, numbers that you can arrive at. Okay, to know how many IP addresses are in a particular prefix length, IP address / prefix length. Okay, so when you now look at a subnet, so remember that we said that if in AWS there's usually availability zones. Availability zones are data centers, right? So whenever you see AZ, don't confuse AZ with a subnet. It's a subnet is now a logical network that you create within an availability zone. That's the difference. An AZ is a physical location, it's just a data center. But once you go in there, you create a small network. Inside that AZ, you have created a subnet, right? So just understand how it differs from subnet. And that's why sometimes in an AZ, you can have multiple subnets, meaning you can have subnet one, and you can say it's private subnet. You can have another subnet inside that AZ and say it's a public subnet, right? But just understand the difference between a subnet and an availability zone. So VPC regional resources, obviously, we've seen that subnets AZ specific, right? So you are building a subnet within an availability zone. And then there's obviously max of 5 VPCs per region, but you can increase that if you wanted to go further than that. Subnet types, you can have public, private, it's just your design. Public is basically it's routable over the internet. Private, nobody can see it from the internet, right? Unless you more or less like expose it. And then best practice, usually multi-AZ, that's the whole idea. So it means that you go to one AZ, put a subnet there, you go to another AZ, put another subnet there, right? Just to make sure if one AZ or one availability zone is impacted, the subnet in the different AZ will continue to handle your traffic, right? Subnet sizing consideration is just what the exercise I was going through just now. Because if you see how I broke it down, I did break it down to, so if I go back to that page that I was showing you, this one, I did break it down, but again, I can extend this as much as I want. So for example, if I go back to the original example, which is the subnet sizing I'm talking about, I can begin to increase this. I can say, I don't want my subnet to be this large. I want a bigger subnet. So it means I just need to reduce this number. So if I do /20, you see the IP address count begins to increase. So you can see here, and I have 4,096, which just means that if I put this as a starting point, it means that first subnet is entitled to having like 4,096 IP addresses, right? Just so you know, and obviously you know that AWS is going to take 5 out of it, and then you can have the remaining to yourself. The remaining is just what are your applications. Remember, load balancers will use IP addresses. Your EC2 instance will use IP addresses. All the RDS clusters we've played with, they're basically using IP addresses from your pool, right? So all those things are things you should consider. Okay, so let's continue. So when you now think about it, what's a public subnet? A public subnet is basically something that routes to the internet, right? And that is made possible with an internet gateway. Okay, so you can't miss it. So just know that something that has a public IP and it has a route that takes it to the internet is a public subnet, right? So resource gets public IP address. So public IP address is number one. That's one thing that makes it routable. And then number two is that there's an internet gateway, because if there's no internet gateway, you cannot see the internet cannot see you. Okay. And we know what should be there. We've seen examples of that. Load balancers, right? Your web servers. Basically, you want them to be seen on the internet. They will be there. But when you now think about private subnet, remember, subnet is just a network block, in a logical network within an AZ, right? So it means that no direct internet access is the keyword to use there. They use network address translation. The whole idea is that they have private addresses, so they are not resolvable on the public internet. But if they are going to go out, they'll use like a NAT device to get the public IP that makes them seen on the internet, right? So there's that translation that happens, and we'll see what that looks like. So example cases is really your database. You don't want your database to be on the internet where somebody will be trying so many acts on it, right? You don't want that. Or you like your application server. Sometimes you don't really want them. Maybe you just want to front your load balancers and you want your application servers or your database or your crucial resources. You want them private, right? And then just front the load balancer. Okay. So that's really the thing. I'm going to spend time here to show you this architecture, because we will not be able to design this architecture full in the class. But I'm going to show you how we can take the default subnet, the default VPC that we have, and extend it with the knowledge we already have. And we are going to see how easy it is. But let me show you. I was actually looking online to see if I could see a diagram that depicts a real VPC, but I couldn't find one. So I created my own. Okay. So I'm going to spend some time sharing it, explaining this diagram for you. Okay. So let me take this away. So every VPC that you see, no matter how complex it is, it's made up of everything that is in this diagram. So just see this diagram as a cheat sheet. Everything is here. And I tried to design because I was looking for something online, but there was nothing like that had it. So I just designed one. The whole idea is that there's something coming from the internet, right? So a traffic is coming from the internet. The first place it's going to reach is really your internet gateway, right? So it's going to reach your internet gateway. Let me zoom it, zoom up a bit. So it's going to reach your internet gateway, and when it reaches your internet gateway, remember I told you that I don't know if I can zoom. Let me still zoom this a bit. I'm not sure how well you can see. Now, you remember I told you of the bigger block, right? The bigger block. And I said it's not just a VPC. It could be org-wide. You could have like your organization using a large CIDR block that has like 16 million IP addresses. And then they would divide those IP addresses across different accounts, across VPCs. That's where the planning happens, right? But when the planning happens, there's something that falls on a VPC, and it's still a CIDR. A CIDR is just telling you that how many IP addresses are inside this VPC. So in this case, I'm seeing 10.0.0.0/22. If I go back to where we're coming from, 10.0.0.0/22, what does that tell you? It means that in this VPC, there's only going to be 1,024 IP addresses. That's what it means. That's what it means. So I've chosen that CIDR to be the CIDR of the VPC. There might be other CIDR that the organization is using, but for this VPC, maybe call it the dev VPC or demo VPC. I've chosen to use a CIDR of /22. And we both know, if you were to calculate, just do 2 raised to the power of 32 minus 22, you are going to get the total number, but it's going to give you 1024 IP addresses, right? What it means is that after getting that, the next thing I want to now do is I want to go back to my drawing and be like, okay, I have this, right? I have these blocks, this 1000, what's the number again? 1024 IP address. Now I need 4 subnets. What should I do? It looks like, so it looks like, okay, I have the group itself being 1024. What will happen? It means that I want to break it into 4 equal parts, right? So 4 equal parts will be, okay, I want one subnet, subnet in one AZ. I need, you remember, an AZ would have subnets, right? Subnets are really the network itself. So in this case, I can say I want a public subnet because I want my application to be highly available, redundant. I want a public subnet in one of my availability zone, and I want a private subnet in that availability zone also, right? That's 2 subnets. Just forget about what they are called, whether it's private or AZ. And I go to the other availability zone and I say I want private and I want public. That's 4 subnets, right? So the next task will be, okay, I have 4 subnets in that VPC. How should I go about it? You just need to split those 4 subnets. It depends on you, but in this case, I think the easiest way is just take the 4 subnets and break it into, take the VPC's CIDR, break it into 4 equal parts. So if you are going to go into 4 equal parts, what I will give you is that if you do the first one being, so this is 22, which is the VPC, right? So if I do 20, I know if I do 24, right, /24 in 4 places, I'll get the 1024 that I have, right? So it means that the first one could be this. So the first one will be this one, 000/24, right? That's going to be the first one. But it also tells you that the next, so the last IP address is obviously 255, right? And 255 is obviously the broadcast address. It means that after this range is done, you would have exhausted the last IP on the right, the 4th octet. You would have exhausted it, right? So it means that the next logical block, right, is obviously I've exhausted this octet. I'll go here and I'll say 1. But if you notice, this is not changing, right? So it means it's really 256 per subnet, right? In 4 places will give me the subnet that I want. So you would have planned this. It is you that will now decide, okay, the one that is 000 is your, maybe the 2 first ones are the public subnet, the 2 next ones are your private subnet. However you want to go about it, it's now your business. But the thing is, I know there will be 10.0.1.0, and then there will be 2, right? And then there will be 3. But if you notice, nothing is really changing. It's just telling you the first usable up to the last usable, right? But it's all giving me a count of 256 in 4 places to make the total count of 1024. That's really all you are doing, right? Whether it's in a small 1 VPC or like 10,000 VPCs, the most important thing is there's a block you are breaking down into smaller pieces, right? But here we're talking about 1 VPC. But like I said, the 10.0.0/24 that you saw, I think it's /22 that you saw there, could be more, could be a bigger block that has like 16 million IP address, and then that is broken down into different subnets. So once I have that, so here what I'm doing is I'm saying, okay, this first 10.0.0/24 is given to my public subnet. On the right, I'm saying the next logical block, which is exactly what I was showing from the calculation, is going back to my second public subnet. So I've done that. So the first 2 blocks, 256 IP address, 256 IP address, are given to my 2 public subnets. And then I'm scrolling down to say the next 2 blocks that comes out after it becomes my private subnet. Remember, so I'm saying those 2 blocks are my private subnets. Now, let's take one subnet. Let's take one subnet. So in a particular subnet, once you create a subnet, there are things that are key, right? Number one is a subnet will have what is called a network access control list. And it's just a subnet layer protection, right? We've seen security group, right? They apply to the instances. But for subnet, you can also add an extra layer of protection on the subnet and choose what can be allowed or denied at a subnet level, right? So that's one key thing you need to understand. So once you design the subnet, there will be like a network access control list for that subnet, right? For the public, for a public subnet is really the easiest. The thing is that for a public subnet, it needs a route table. All of them need route table. So route table is not something you should play with. A route table is just how the subnet decides how am I going to go out? Like, what am I to do, right? So when you see this public route table right now, the diagram I did put here is shared between the 2 subnets. So you can see I'm associating it to a subnet on the left, public subnet, and I'm also associating it to a public subnet on the right. But what are they doing? There is 2 routes there that say if you are going to the internet, use the internet gateway. But if you are going within the local network, right? If you are going within the local network, please use if you are going within the VPC, use the local network, right? So we have that. And then there is now the concept of NAT gateway, because if you put this guy in the private subnet and you say you cannot go into the internet, it still needs a way to do things. Like maybe I want to download files from the internet, or I want to do things. I still need a way to do that. And that's where the concept of NAT gateway comes in. But the way NAT gateway works is that you have to throw it in the public subnet. So it's here. It's just you have 2 in this case. because you just want it to be redundant, right? Remember, you always plan for redundancy. So you have like two subnets in two AZs, two subnets in the other AZ, and then you keep one NAT gateway here, keep one NAT gateway here. And that's why you now need two private routes in this case. You are saying for this subnet, if you're trying to go out, please go to this NAT gateway, right? And the NAT gateway already, so there's a route that says if you are go out, go through this NAT gateway, and then the NAT gateway is going to use the internet gateway to go out. On the other side, you're also saying that if you are trying to go out, use this route table. If you are going to the internet, use the NAT gateway that is on this availability zone, meaning you're not traversing, right? You're not from here going to the other AZ. You're pretty much be like, I'm on this AZ, I want to go to the next one. Sorry, I'm in this AZ and I want to go to the NAT gateway that is in this AZ, right? And once you go to the NAT gateway is going to route you to the internet, because that's what it does. It basically gives you a public IP address that allows you to speak on it, behave on the internet, right? So it masks your private IP and then gives you like a new identity. And then honestly, that's it. Like this diagram that I have here, if you understand this diagram, VPC is not going to be, there's nothing else in the VPC. And I keep saying many of the organizations, I think the only thing is that it depends on the experience you have. But for beginners, just know that as you grow, most VPCs you deal with, it's these VPCs in 10 places. That's just what it means, right? So at the beginning, somebody will design more or less like pick a CIDR range. I'll still mention it. You start with a big CIDR and then break it down. Be like, okay, for prod, this is the CIDR that you're going to be using. For dev, this is the CIDR. You just create logical blocks, and then within there, you now break it down. Remember, this is just a two subnet example. You can have multiple. Depends on how many AZs you have within your region you're working with. But if you can follow this, you can also design more. You can say, okay, I have availability zone 1, availability zone 2, put two subnets there, put two subnets there, create more blocks, right? Just depending on how much this CIDR accommodates, okay? So the diagram is here. Everything you need in a VPC, I think I've tried to put it here. It's also the diagram I was sharing there. It's just that it's going to be hard to really show you clearly. And that's why I brought you to the draw.io page that I was using. But everything we're going to be seeing about the VPC is here. And we're going to play with just a part of it, okay? So let's continue our slide. So this is the same diagram, so I'm not going to talk about it. That's the diagram I was showing you. It's in the slide. So route table, honestly, I think I've explained it, but I'm just touching it here because it's in the slide. So usually route table just determines a subnet will not know where to go unless there's like a route table that says, please, I want to go here. How do I get there, right? So it determines the traffic direction. Every subnet must have one, right? So usually when you create, there's a default route table that's given, but you need to go back and there and tell it exactly how to go anywhere. You know why? The reason is now we're talking about VPC, but when you start talking about advanced object like transit gateway, advanced networking concept, that's where route table becomes very powerful because a subnet needs to know how to get out, like do anything, right? So main route table default for new subnet. So there's like a default route for the when you create like a subnet, it takes the default route table. But ideally, you're meant to give it like its own specific route table and decide exactly where it should go, right? So custom route table is what does that. So explicit association, you can say go here, right? And then route priority, most specific route wins. That's one thing with networking that we'll see as time goes on, is that when you have two routes, the one that is most specific is really the path it's going to take, right? And then there's always the local route always present, which is what the quiz was asking about, right? So when you create like a default route table, there's like a local route, which is just like, how do I see other services that are within this VPC, right? Cool. So internet gateway, like I said, it's a managed service, right? Provides internet access for public subnet. So if you want to go to the internet, that's what the internet gateway does for you. It's in the public subnet. But again, private instances can also use it, but that's where NAT gateway comes in, right? So one IG internet gateway. So when you see IGW is internet gateway, per VPC, that's the maximum, one to one, right? It allows bidirectional traffic, obviously. When you send traffic to the internet, you want to get response, right? So no bandwidth constraint or single point of failure. Obviously, it's managed service. AWS handles the scaling behind the scene, right? Required for public subnet designation, right? So meaning if you want to go from the public subnet, you need an internet gateway to route you to the internet, right? Okay. So when you think about, we've talked about, if you look at the diagram, we saw that for a public subnet, you need like a internet gateway, right? That one is straightforward. But for the private subnet, you need a NAT gateway, right? Like I said, your private instances have private IP addresses that don't have identity on the internet. They're only known within your local network. And for you to go out, you will now need a NAT gateway. It's basically network address translation. So when you're trying to go out, it gives you an IP address that can allow you to talk on the internet, right? So it's an AWS. So there are two options. NAT gateway is AWS managed service, right? Highly available within AZ. Obviously, bandwidth scaling, it can do that on your behalf. Automatic software update. So there is like an option to use to NAT gateway. AWS will manage that for you. But there's also NAT instance, which is legacy. Nobody encourages you to do that because you're just deploying an EC2 machine to do that same work for you, right? And yeah, people use that sometimes in their dev environment or their testing stuff and all that. But for the most part, most people will fall to use NAT. You know how it is. Like in AWS, we always like to use managed services, right? Right. But yeah, you need to do like some manual configuration. Obviously limited also by the instance type, the bandwidth on that instance type, right? Because you're using it to do your NAT needs. It means that the bandwidth will also constrain what you can do. Okay. Security groups, I won't spend time here. We've used security groups severally. You know, right? Firewall at an ENI level, meaning if there's an instance, for example, we've seen it whether around database, whether around EC2 instance. So it happens on the instance level. It's a firewall. It only allows only like allow rules only, right? You don't have like deny block, right? Because obviously it's stateful, right? So the return traffic is always allowed. So when you go, if you can get to an instance, you can always get the return traffic, right? Yeah, we've seen that we could attach multiple single SG to multiple instance. We can attach multiple SGs to a single instance. So it's like a many-to-many relationship, right? We've seen that security groups can also reference other security groups. So we're not going to spend time talking about it. So outbound is also allowed. But here, the concept of a VPC, there is a concept of network access control list, right? It's subnet level firewall. So the other one was instance level firewall, and here is subnet level firewall. So you can choose where a subnet can go, right? And remember that you have to reach the subnet before you reach the instance. So if something is already blocked at the subnet level, you can't get access to the instance, right? So in this case, it is stateless, meaning you have to explicitly specify your outbound and your inbound traffic, right? So allow and deny rules are also supported. That's the difference. Security group only allow rules, but network access control is allow and deny, right? Rule evaluation is one of the things you need to take note of. So the lowest number will win. So if there is like a rule in network access list that has the lower number, is going to win over. So you have to order them, right? And then the default NAT obviously is to allow all traffic, but you can go there and play with it. And then you can now have like your own custom network access control list to deny all traffic if you want, and then put only the traffic you want, right? So when you think about security group versus network access control list, like I said, one is instance level, but network access control list is basically subnet level, right? So you have to take note of stateful versus stateless. That's one thing that confuses a lot of people. Best practice, use both, depending on your need, right? Connectivity, check both. But most times, because the default subnet, the default network access control list is always allow, and most times people don't really check subnet. Most times the problem always comes from security groups, right? Unless you misconfigure your network access control list, okay? VPC flow logs is something that is within a VPC. So what it means is it captures the flow of your VPC. So how network is moving through your VPC captures that flow, and it's a log that shows what exactly happened, whether it was an accept or a reject. Right? We won't spend much time talking about it, but just know that it captures traffic at an ENI level, right? And the elastic network interface, and then you can push the logs to different locations like CloudWatch, S3, Kinesis, data firehose, right? And the reason is because you can use it to troubleshoot. Okay, I'm not being able to access my application. You can begin to see why are you being blocked? Is the traffic being rejected? And also you can also use it for analysis to see exactly who is accessing your stuff, right? You can check IP, because here you can see the source versus the destination IP address. Okay. But one thing you should know that within your VPC flow log, you can't find DNS traffic, right? DHCP traffic, all those kind of traffic. You won't find them inside. And it's also good. You can also use that because you can get those logs. You can do real-time monitoring on it, right? So if you wanted to track something that was going wrong immediately on your VPC or your network, that's really a good place for you to keep an eye on to capture those kind of events, right? So let's with all this knowledge, this is basically for us to go back into the default VPC and then see how those elements that we've seen, how it comes to play, right? So let's go to my account. So that's really what I want to show you next. So if you go to your account, you will see that there is a default VPC. So I'm just going to try to come here, come to this place and open this page in the other browser so that I'm not context switching. So I'm just going to come here and paste this here. Okay. So this is here. So let's look at the default VPC. So the default VPC is currently here. We have just one, right? But one thing I'm sure of is that, and if you check the subnets on the left, so if you check the subnets on the left, they're like 4 subnets, right? So it came with the account. So I'm just going to show you what they were thinking when they were designing it. So I'm going to take the first side here and I'm going to paste it up here, right? So it's 10.31. So it's 10.31/0/0 and then /16, right? So it means the default CIDR is generous. It means that there's like room for 65,536 IP addresses. And by now, I think I told you exactly how to find the calculation. You do 32 minus 16, 2 raised to the power of that, right? So if you think about it, like I said, it now depends. So it depends on how you now want to break the subnet. But if I look at their own console, I can see in the subnet, there is already, they created the first one. So let's look at the first block they created. They created 31, so 172.31. I don't really care that much. I'm looking at the /20. So if I go here and say /20, it means that the first subnet they created is 4,096 IP addresses, which is fine, right? And then obviously, I think if you can see the first usable and the last usable, you have to pay attention to the last usable, right? because I know they've exhausted this block. So in my own assumption, I can completely say that the next block is going to start from this second one, this 15, right? So I would say the next block will start from 16. And once I know that, because it's a block of /20 they are using, I will know that the next one will be 32, right? So if you go and check, you obviously see 16, you see 32, you see 48. You see 48, right? But if you see it, it's the same block, because if you, so if you do it, I think it's 48, right? So it's 48, correct. But if you see, this count is not changing. So they have fixed length of the subnet they have created for the default VPC. So if I want to now look at this, because obviously we're not creating like a VPC in this class, like it's a different ballgame, and this is like beginner's class. But if I compare these to the diagram, I can see that they already have things for us. The only thing is that they have public things. They don't have anything private, right? So for example, I know that they created this subnet. There was a large VPC CIDR. They broke it down into different 4 subnets. And then for that particular VPC, there was already like an internet gateway, right? So there's an internet gateway that was attached to the VPC. Once that was done, I think they created, there's just maybe one route table. So if you go here, there's like a route table. And in this route table, it is associated with those 4 subnets. Like I mentioned, the subnet needs to know how to get out. So in this case, there were already 4 subnets that were already attached, right, to that route table. Meaning these 4 subnets will know where to go, okay? And then what else? That's basically it. So, and every instance we created will have a public IP to use the internet gateway to go out. So in this exercise, what we'll be trying to do, because we know this pattern, let's create our own. Let's create our own private subnet. Let's extend the public subnet that we have here to create our own private subnet, right? That will not have public IP address, but would be able to go to the internet, right? Because of the knowledge we now have. Okay. So how do we go about that? Let's go back to the VPC. So we'll go to the subnet, right? There is 4. The last block that was chosen, you can't really have overlapping CIDR, right? It means that you have to have like very distinct CIDR blocks. So I know that the last one that was created is /31 172.31.48/0. That's the last one that was created. I can create my own as the next one, right? So I'll go here and I'll say if this is 48, obviously if I add 16 to it, right, and still keep this prefix block, that's where I should be. So if I do 48 plus 16, 48, let's say, plus 16 will give me 64. So that's a good block to use. Already, you can also tell from here, right? Because the last usable block stopped here, right? And broadcast IP or address is already 255. So I know the next logical block should be 64. So I'm just going to come here and say 64. So I now have a new subnet. I have created a subnet from that same block, and it has 4,096 IP addresses, right? So let's create our first subnet. So I'm going to use, I'm going to create a subnet. So I'm going to create a subnet. Remember, all those other subnets were created in an availability zone. In this case, I'm going to create my own private subnet in one of the availability zones, right? So I'm going to do this. So I'll create this, right? So I'm in the same VPC. I'm trying to create a new subnet. So I'll go here. I'll call my private subnet. I'll just be specific. You can name it whatever you want to call, but because I want it to be an AZ1 in an availability zone, right? So I'll say my private subnet AZ1, right? So availability zone, I'm choosing. I really want it to be in a particular AZ. So I know there is AZ1 here, AZ2, AZ3, and I named it AZ1, so it's going to be there. Now, there's already a CIDR from the VPC, right? This is the block of this VPC, but we just realized that we want our AS will be .64, right? So it's going to be 10. It's going to be 172. I think I was using 10 dots, but I think it's actually 172. Okay, but it doesn't matter. I'm just going to come here and do 171.31, right? .31.64, right? .0 slash. Remember, the block we're using in this case is /20, right? Equal blocks, basically equal blocks. So if I do this, you can see it's the same 40996 IP addresses. It's the same calculation that we saw here. We could see it's 4096 IP addresses. So it's the same. It's just that AWS is obviously going to take 5 out of that, right? So it's here, and we've named it correctly so that we know that it's our private subnet. So we'll create a subnet. We've created it. So this is because we understand the structure. It's why I can extend someone's VPC, right? Because some people cannot even extend the VPC. They depend on creating theirs. You need to be able to understand the VPC for you to be able to go to an existing VPC and extend it, which is what we just did, right? So now I've extended our VPC. I've created. So if I undo this, you see that I now have my own private subnet. You can see 5 IP addresses has been taken away, right? AWS will take that. But you can see there is one public already here, and there's now the new private that we added, right? Cool. Let's continue. So we know that if you look at this subnet, right now, it was given a route table, right? So it was given the default route table, which says if you want to go to the internet, use the internet gateway. If you want to move within the VPC, use the local route, right? But I need to create a specific route table for that one. I need to create a specific route table. So what I'm going to do is that I'm going to go and say route table. I'll say private AZ1 route table, right? So I'm going to call this. The VPC is still the same VPC, right? So I'm specifically naming it private AZ1 route table, right? So that this route table is what everyone in the AZ1 can use. So I'm going to create that. Cool. So once I have that, right now there's no subnet associated with it, right? So remember that the subnet needs to be attached to a route table. But when we check the private subnet, it was already attached to the public route table. In this case, I need to tell it, no, I need it to be attached to the private route table, right? So I'm going to go edit the subnet association, and there I'm going to bring this guy in and save it, right? So now what it means is that I've associated the private subnet to this private route table because I know the routing for this guy is going to be different. So which is what I've done. So if you go, it's associated to one subnet. And if I go to my subnet, for example, I see this guy. If I see the route table, yeah, there's only one route right now that says go to this. If you are going to anywhere in the VPC, use the local route. Cool, that is sorted out. So if you look at it, if we go back to the diagram, for example, what did we do in the diagram? What are we trying to do? We have extended it. The default public subnet, the default VPC came with what do you call it? I'm not sure where I was just now. Oops. Let me see. Where was I? I just did something and now I can't even find my other pages. Let's see. Okay, page tabs. Okay, I think I need to be here. So going back to it, you see that the public subnet basically were given to us. What we are doing is that we're extending it. So we just created a public subnet, a private subnet. We created a private route table, right? Right now there's only one route that says if you are going within the VPC, use the local route. That's all we have. The next thing we need to now start doing is let's create an instance. So let's go back here in the private subnet. Let's launch our first instance in that subnet that we created. So I'm going to go to EC2. In EC2, I'm going to launch an instance. So I'll launch an instance in that private subnet, just so you understand what are we trying to solve. So we will launch an instance. So we'd say I'll just call it my private instance because I know it's going to be private. So private instance. So my private instance is here. I'm going to keep the Amazon image the same. I'm not going to touch it. I don't really need to keep here, okay? But this is where I need to edit this, right? So it's the same VPC, but subnet, I have to be specific. I want it to be in my private subnet, right? I think all the times we've been using creating EC2, we've been putting it in private subnet. Here I'm saying put it in a private subnet. Here I'm also disabling not to assign public IP. It won't have a public IP, right? I want to create a security group. I'll call it my private, just so that I can remember. So I'll do private private EC2 my SG, right? So my private EC2 SG, I'll just call it my private EC2 SG, okay? And that's the description I'm giving it. Now, this is where I'm going to be like, okay, SSH for now. I think I would do something a bit because usually private subnets you basically need to be able to you can't just access it, right? You have to go through a bastion host and all that. But I want to avoid all that. I want to show you like best practice. So I'm going to do SSH. But in this case, so it's SSH, which means TCP port 22 from anywhere. But I'm going to do not anywhere, custom. In this case, I'm going to do instance connect. So instance connect is really what I want to getting into this machine. Okay, I'll leave every other thing as default. So I'm going to leave every other thing, and then I think everything is fine. I'm just going to launch it. The most important thing is that it's been launched in the private subnet. That's the most important thing. So I'm going to launch the instance. I think it's requiring me to create a new key. I don't need to proceed without a key pair because I'm not going to do all those key download and all that. So it's creating an instance in the key pair. While that is ongoing, because I want to be able to get into the machine, I'm just going to go to my VPC and create an endpoint. Don't worry, there's a specific class. I'm going to break down endpoints, but for this demo, I'm just going to show you something quickly. There is already this one that is deleting. It's gone now. I'm just going to create a new endpoint. So I'll call it EC2, my EC2 instance connect endpoints. There's a reason I'm doing this because I don't want to access that machine using the public space. So VPC is still our VPC, so I'm going to create it within this VPC. In the subnets, I'm going to use the private. So for the security group, I'm going to check this security. I think I used to have one security group here, but in fact, I can create a new one. So I'm going to create a new one while we're on this call. Let's create a new one so that you understand what I'm trying to do. So security groups, I'm going to create a new one here. There's really nothing here, so I'm going to create one security group and call it instance connect SG, okay? And then I'll say allow connection to instance connect, okay? So it's in the VPC. The inbound rule in this case, because I'm doing it from the outside, so I'm just going to allow all, for example, allow traffic for now, all traffic, okay? Cool. So it's there. I'm just going to create that. So instance connect SG. That's the name. So I'm allowing all traffic to the instance connect SG. And now while we're here, I'm going to go back to the old SG that we created. So this private SG, this one, my private EC2 instance SG, I'm going to edit the rule. So instead of allowing instance connect, I'm going to allow, instead of allowing the instance connect, I'm going to allow the SG of the instance connect. So instance connect SG. So I'll delete this, add a new rule for port 22. So SSH, and then I will say SG. So I'm going to call it instance connect XG, right? And then I'll say allow connection from instance connect. Okay, save rules. So now we have that. And then in the first place, I was trying to create a VPC endpoint. So go back to where was I? I was in VPC endpoint. I'm going to refresh this page. Yes, so I got one here, right? So allow connection to instance connect. I'm using that security group. In the subnet, I'm going to use my private subnet, right? And then once I have that, I'm just going to create endpoint. Let me repeat. What am I doing? I created a private subnet, right? A private subnet will not have anything. It can't really be accessible. So if I wanted to connect to that private subnet to show you what I need to show you, I have to create one instance in the public subnet and then do connection to it. But here I'm also showing you a fast way to basically gain direct connection to that private subnet, right? By using instance connect. So that's why I'm creating an endpoint for it. Okay. So we'll give this endpoint time to create, right? But let's go into our EC2 instance. So our EC2 instance is here. It's running, right? The only problem right now is that it's running, but I can't connect. There is no way I'll be able to connect unless I'm using something that's in the public subnet to connect to it, which is what I'm trying to avoid. So the instance is creating. We'll just give it some time. While it is doing that, I think if you go back to the diagram, we already have the subnet itself, right? So we created the range, we created the subnet. We've now thrown an instance into it, right? And the security group of the instance obviously allows us to gain SSH into it, right? I think the only thing we now need to solve is that, can we get to the internet with that instance as it stands? That's the next big question that we need to answer. So right now, I think the only thing that is missing is that we need a NAT gateway for us to be able to do that, right? But again, I'll prefer the instance come up first, and then we'll see that we can actually connect to the internet until we create that last configuration there, okay? So let's give it time. While we're there, let me just go back to the endpoint, refresh. This one usually takes a bit of time, but we can give it its time to, because right now, if I just go and create a gateway, you'll see it working. But I actually want to show you that it doesn't work at the beginning, and then we'll create that same configuration again, edit the route table to make the connection work, and then we can actually now see that it's working as expected, okay? But the instance is running. It's just that right now there's no way to connect. So if we do instance connect, we can't use public IP. The guy is not routable on the IP on the public internet, right? Session manager also, we still, because it's a private instance, we need to do more for this to happen, right? Just the same thing I did with instance connect. SSH client obviously no, and then so we have just these two options, right? But again, I actually want to connect using a private IP, so that's what I'm doing. That's why I went through that first step. But again, don't worry, we'll do endpoints, and I'll break endpoints down for you to understand how this is made possible. So let's give it some time. Right now, I think I can try to see. Create is still in progress. EC2 user is the word. It's not going to allow me because the create is still in progress. So we still need to give it some time. So let's go back there. That's why I say sometimes, when you do this in a live call, it's not easy for you to, like, ideally in cases like this, I could pause and just wait, and let it pass and then show you the result. But sometimes because we're doing it live, we have to wait. There's like a wait game for you to see the exact result, right? So in this case, we are just waiting for the endpoint to be up. Remember, I could have as well done this in a different way. I'll create an EC2 instance in the public subnet, connect to the EC2 instance in the public subnet, and then use key pair to go into the private subnet. But I'm just avoiding all that completely, and I want to gain connection directly to the private subnet, right? But for that to happen is why I did all the small configuration that I'm doing here. So let's just revise what it looks like. It's using a security group, and if you check the security group, the rule there right now is that I think the rule there right now is using this instance connect security group. I think for the most part, I need to edit the inbound rule. Yeah, for this one, I need to actually add a rule because you will need to connect via HTTPS. Okay, so it's HTTPS. For now, I'll say anywhere IPv4. Okay, so allow connection to instance connect. I thought I wrote this before. I don't know why I'm having to do it again now. But let me save the rule, and then also just have to outbound rule is fine. So the instance connect rule itself has something that allows in. Oh, sorry. I think this is HTTP instead of HTTPS. It's supposed to be HTTPS. So HTTPS. Cool. That's what I want because instance connect is going to happen on that port. So I'll save the rules, right? So this is, I think the next thing is, let me just check the other security group and be sure. So the other security group, private instance, is expecting connection from the EC2 instance connect SG. Cool. On port 22, which is fine. So we now just need to check our endpoint to see if it's available. It's still pending. Usually just takes some time to provision, right? But let's go back to our diagram. So the only two things that are missing here Right now, the route table itself is private. We have a private route table. We just don't have the route that takes us to the NAT gateway, right? But again, I want to show you that at the first time where we're creating that EC2 instance in the private subnet, it's usually going to be, you can't go to the internet until you create this configuration, right? So that's the only thing. We'll edit the route table, add that rule that takes us to the NAT gateway, and then we'll provision the NAT gateway. And that's it. That will be what I really wanted to show. But the learnings here is that we didn't really create a VPC. Rather, we saw a VPC that was already existing. And because we know the components that a VPC need, we just extended the VPC. And you need to grow up to that point whereby you can see the component of a VPC and be able to attach something into it. Honestly, at this, because I'm talking to people who are doing CCP, I'm not supposed to stretch it this far. I'm supposed to just introduce the subject. But that's why you see I'm not going to the route of we're creating a brand new VPC, doing all that. Rather, we're just taking the VPC because we know the elements and we're taking the shortcut of adding a subnet, and showing all the elements that it takes to introduce a new subnet and all that needs to happen, right? Which obviously, if you can do that, the other ones are really simple because you just need to start with a CIDR that is big, break it down into smaller CIDR, and then use that to create your subnet, right? It's not hard. But I'm sure at some point we'll do more advanced stuff. So it's not available. So let's try our connection. So if I refresh this, it says it's complete. So I'll try to connect using Instance Connect right now. I hope it connects. Okay, so I'm in, right? So I'm in. This is a private subnet. This is a private machine that doesn't have a public IP, but I'm connected. I was able to SSH into the machine, right? So, but one thing you will know is that if I do curl and I do www.google, right? So google.com, right? It's not going to work. Right now, this guy is not, it's private IP. Nobody knows it on the internet space. Even if I do ping google.com, it's not going to work, right? It's just going to hang there, right? So it means that we have a private subnet, something that is not, nobody can see it. We now need to create that connection for it to happen. How will that happen? In the diagram, it shows you can have two, and the reason is just because for highly available. So for an highly available setup, it means that if you have a private subnet, it should reach the NAT gateway in the same availability zone. And then if you have another one here, it should reach the NAT gateway in its own availability zone, right? So let's go and create a NAT gateway. This is going to stay here for forever until we solve that problem. So we'll go and create a NAT gateway. So we'll go here and say a NAT gateway. We'll create one, and we'll say private AZ1 NAT, right? Sometimes it's good to name things well. Okay, so NAT gateway, just to show that it's on the AZ1, right? Because that's where we were doing things. And it's going to be, remember, so it's going to be public because we want, it has to be in the public subnet, okay? So public AZ1 NAT gateway, right? So the subnet itself, check very well. We need it to be in US West 2A because that's where the private subnet also is. So we'll put it here, US West 2A, right? The connection is obviously public, we want it. But this is where the magic happens because it's doing network address translation, you need to allocate an elastic IP. So once that is done, that's really all I need to do. I'll create a NAT gateway, right? So once I have a NAT gateway, right, that is already, I think it's just going to take some time to, it's pending. So it's also going to take its time to be available. But this is managed service, right? AWS is doing the management on our behalf. While that is ongoing, we now need to go back to our route, right? Remember we had like a private route table that a private subnet and that EC2 instance is using. So we'll just go there and do route tables, right? We'll go here and go to the one that is private. So click on this one. And then we need to edit the route. Right now, it knows how to move around the VPC. It just doesn't know how to go to the internet. And then we'll add a route to say if you are going to /000, we want you to use a NAT gateway, right? And then use the NAT gateway that we're provisioning right now. So we'll save the changes. But it's all within the same AZ, so it will know how to get in there. So it's there already. And let's see the NAT gateway being created. So if we go back to the NAT gateway, it's still pending. So we're just going to give it some time. But if you understand the concept, right, we did create a public subnet. We had public subnet already available and we just extended it. So we created it. So this is being created in the public subnet. And then if you go back to your diagram, it's really exactly what I was showing you. Something that is in the private subnet is going to use the route table. Right now we said, the route table should take you to the NAT gateway, and then the NAT gateway is going to route us out, right, to the internet. So with that already said, let's just give it time to be available. We just need it to be available, and then we'll test if we can go out to the internet. And once that can be done, yeah, we've actually introduced VPC. So let's give it some time. Now, also, there's just something I need to tell you. Right now, all of them, they are using, if you think about it, all the subnet, 5 subnet, they are using the default network access control list, and it's fine. I don't have any specific requirements. So if you check the default subnet, you see that it has like a rule 100 that allows, right? Outbound rule, it also has a rule 100 that allows, right? So I don't have any specific requirement. Ideally, I'm meant to create one for my subnet and use it. But in this case, I don't really care. I can use the one that is there because I know it allows both inbound and outbound traffic. But you can control it at the subnet level. I can say, I don't want any traffic to come to my subnet, this particular subnet, and limit it, right? But right now we're not doing that. But we know we can always edit this inbound rule and add more rules, and we said it's in order, low to highest, right? So to evaluate from the one that is lowest and down, right? So let's go back to VPC. Let's go back to our endpoints and see. Sorry, I think it's NAT Gateway. So let's see if it's available. Now it's available. So um, so because we now have a NAT Gateway, yeah, you can see I didn't even have to do anything. Just going back, you can see the request is now coming in, right? So it's working now. So what it means is that I can also do the same command that wasn't working before. I could do www.google.com, right? Yeah, and I did get a response, right? Um, so yeah, I can't get to Google now, right? So request status 200, right? So that's really what I wanted to share for this class. I don't want to extend it beyond this because we usually record these videos and put on my page so that you can go back to it. I don't want it to be too long, but that's really the concept. I did share a diagram with you. This diagram has everything you need. The most important takeaway is that everything you see in the AWS world has like a very huge CIDR that is broken down into smaller CIDRs. In this case, think about this VPC as a CIDR that has been assigned. So this small VPC was given a CIDR, right? And then within that CIDR, it was broken down into other CIDRs for the different subnets. So in this case, we used like the public. There was already a CIDR that was assigned. There was like 4 subnets, and we just extended it by just creating one CIDR and giving it a private subnet, right? Usually, I'm supposed to add cleanup in this place. So yeah, you can just go back. Ideally, you're supposed to go back, clean up, like delete the instance, delete the NAT gateway, delete even the endpoints that we created. You can do all that deletion. But the most important thing is that this guy right now, it's a private subnet, but it still can go to the internet. Number 2, I was able to use more or less like I had to bypass the need for me to use a bastion host like in the public subnet to get to it, and that's why I created that endpoint just to allow me get into the machine directly. Okay, so with that, I think we're good for today. I wouldn't want to stretch it beyond this point. When we'll meet next time, we'll still talk about the other part of VPC that I needed to know.